Okay, so this chapter / chapters 5 and 6 is all about systems of equations. Okay, now I know that we spent a whole long time on systems of equations in Algebra 2, but I just want to kind of go over some of this stuff with you. There's a little bit of vocabulary difference, not a whole lot. You'll be fine even if I didn't say anything about it, but I wanted to go over that with you just to make sure. Okay, so first of all, do you know how to solve a system of equations using substitution? Yes or no? Yes? Do I need to go over that with you, or you got it? Like do an example or no? Yes? Okay. So if we had x plus 3y equals 10, and if I also tell you that y equals 4x minus 14, how could I solve this system of equations using substitution? Well, you know what y equals, right? Y equals 4x minus 4. Why don't we just put that in for y? So let's rewrite the first equation, x plus 3, but instead of writing y, I'm going to write what I know y is, which is 4x minus 14. Does that make sense? So we have x plus 12y minus 14 times 3, 42. You okay so far? Now let's combine our like terms, things that we already know. 13x minus 42 equals 10. When I add 42 to both sides, I get 13x equals 52. Dividing both sides by 13 gives me x equals 4. Do you know 52 divided by 13 is 4 off the top of your head? Do you know how I know it? Cards. There's 52 cards in a deck, right? And there's 13 in each suit. How many suits are there? 4. Yeah. Is this it? Let me ask you one of the most important questions about systems of equations. What's the solution? What's the solution to a system of equations? It's where they cross, right? Their point of intersection. So if I know that x equals 4, is that all I need to know? I also need to know y, don't I? Okay, so I know that x is 4, so I'm going to take it and put it right back up into that equation, because that equation's already solved for y, isn't it? Y equals 4 times x, which is 4, minus 14. So y equals 16 minus 14, so what does y equal? 2. Guess how we write our answer? As the point of intersection, the ordered pair, right? Now think about this. If you have two lines, two linear equations, I have one possibility. Well, how about if I move it so you could see it? Would that help? Okay. I have one possibility that says one line goes here and one line goes here, right? Like if I graph those two and plot it, that's the point of intersection, right? So there's one real solution, one solution. Is there any other options? Can I get two solutions from two lines? Will two lines ever cross in two places? No, but I could get this. There's the first line. There's the second line. How many solutions is that? Infinitely many solutions, right? Are there any other possibilities? None, right? There's one line. There's one line. Where do they cross? They never do, so there's no solution. If you'll keep in mind that what we're looking for is where they cross, that helps a little bit, doesn't it? Okay? So solving by substitution is important. You need to be able to know how to do that. I don't know why I can't talk today. It also asks you to solve with the addition method. Did we ever talk about the addition method in Algebra 2? No, we did not. We called it elimination. excuse me. It's exactly the same thing. It's just called something different. Okay? X plus 3y equals 11. 3x plus 2y equals 19. How would I go about solving that? If we're trying to solve it with elimination or addition. What's our goal? Exactly. Get one of the variables to cancel out. Eliminate one of the variables. So what I need are either the x's or the y's to be related how? Starts with an O. Opposite. Okay? Which one would be easier to make opposites? The x's or the y's? So you think the y's. First question is, does it matter? No. Okay? We could solve it by eliminating the x's or the y's. Somebody said x's, so that's what I'm going to do first. So what if I multiply the whole top equation by a negative 3? Would that help? Because that would give me a positive 3x and a negative 3x, right? I'm going to multiply it by negative 3 and I'm going to write it below it. Are you okay with that? So I get negative 3x minus 9y equals negative 33. Now do you see why they call it addition method? Because now what am I doing with these two equations right here? I'm adding them together, right? We always said combining, so we didn't worry about the actual thing that's going on, because that might look like subtraction, right? It's okay. I'm not judging them. They don't know. I mean, maybe they do. I just need to shut up. 3x minus 3x is 0. 2y and a negative 9y. It's a negative 7y. 19 and negative 33. Is it? Negative 14? Okay so far? How do I solve it? Okay, divide both sides by negative 7, so y equals what? 2. Is that my answer? Got to find x, right? Got to find both x and y every time. So, is it alright if I choose the top one? Or is it alright if I choose the bottom one? Which one would you choose? Top one because it's easier. Yeah. X plus 3 times 2 equals 11. So x plus 6 equals 11. So x equals 5. So my answer is 5, 2. Yes?